So we have to prove under root 2 is an irrational number. We assume that square root of 2 is a rational number. Now, if it is an rational number, it can be expressed as p by q, where q is not equal to 0 and p and q are co-prime. I hope everyone knows what is co-prime. Co-prime means they have nothing common as a factor. Na p और q में कुछ भी ऐसा common नहीं है. Now, since it is an equation, in equation, whatever you do on left side, right side, the equation remains true. So what I do, squaring both sides, right? So I've assumed that root 2 is a rational number. So after doing that, what I'm doing, I'm operating on both sides. So that means if you square something and we find that they are not negative, we are not assuming any of them is negative, because squaring a negative number may give you a different result. So since they are positive, I square both the numbers and I get p square by q square. On rearranging, I could see the expression like this. Square of any kind of integer, maybe because p by q could be integer, but square will be positive. So p square means a positive number, right? Positive number के ऊपर यूक्लिड ने क्या बताया था? According to Euclid, two is prime factor of p square. Means, see, it is a positive number. Just look at the expression as a positive number is equals to 2 times some integer and remainder is 0. So that means 2 is the factor of p square. This also implies that 2 is also prime factor of p. It is also, this is nothing, I wrote wrong. 2 is a prime factor of p square, so 2 is also prime factor of p. अभी हमने देखा कि स्क्वायर के जो प्राइम फैक्टर होते हैं उसके बेस के भी वो फैक्टर होते हैं. So we'll mark this as 1. This information means if 2 is a prime factor, according to Euclid, we can write p is equal to 2 times m, because 2 is a factor and remainder 0. So what I do, I mark this as a and again square it, squaring both sides. This will fetch me p square is equals to 4m square. Now you can see from equation A and B, p square is equals to 2q square and p square is equals to 4m square. Can we equate them? Since both are p square इसके बराबर, p square इसके बराबर, Euclid axioms, if equals are equals, then the results are also equal. So what this infers, this implies 2 cancels with 2 and we see that q square is equal to 2m square. Again, Euclid division lemma, what it tells, division lemma, you have to mention Euclid's division lemma. basically. It's not Euclid, division lemma, right? So 2 is prime factor of q square. Also 2 is prime factor of q. We are saying 2 is prime factor of q. We are saying 2 is also prime factor of p. Over here, what we said? Co prime. We said they are co-prime, but over here they are having a factor, common factor. Since 2 is prime factor of p as well as q, our supposition is wrong. Hence, root 2 is an irrational number. हमने माना था रैशनल, और वो तो नहीं लग रहा, तो फिर क्या लग रहा है? रियल नंबर में और कोई नंबर सिस्टम नहीं होता, तो इसलिए ये irrational. This is called method of contradiction. I'll repeat. 4 bells toll at an interval of 8, 12, 15 and 18 seconds. All 4 begin to toll together. How many times they toll together in 1 hour, excluding the one at the start. We are given 8, 12, 15 and 18 seconds, and the question demands when they will tongue again together. So that means we are looking for more seconds. We are looking for a greater number. 8, 12, 15 and 18, we are looking for a bigger number. And when we are looking for a bigger and a common, that is LCM. So we are looking for LCM since they will toll together more than 18 seconds. We are looking for greater number than the given numbers. So I'm writing an explanation over here, right? You need not to. You have to sense that you are looking for bigger number than the given numbers, and that is only thing LCM, the least common multiple, because bigger could be many, but we are looking for the smallest common multiple, least common multiple. So we do the factorization, and when we took into factorization of 12, that is 2 into 2 into 3, and then we have 15, that is 3 into 5, and finally 18, 2 into 3 into 3. So LCM is product of all the possible prime numbers available with the highest powers. Highest power only. So 8, 40, 40 and 9 is it 360? Is it 360 now? Just let me see.
Yes, sir.
Yeah, 360. 360 seconds. So 360 seconds mean what? 6 minutes. 360 seconds means after 6 minutes, every 6 minutes, they are going to told together. So how many times, how many 6 minutes do you have in 60 minutes? 1 hour, na? This is what they have asked. So after every 6 minutes, they are going to toll together. So how many 6 minutes you have? 10 times. 10 times they are going to toll together, because after every interval of 6 minutes, they are going to toll together. Two tankers contain 850 liters and 650 liters of petrol respectively. Find the maximum capacity of a tanker which can measure the petrol of either tanker in exact number. So when you look into these questions, you have two numbers here, 850 and 680, and they are asking for a common tanker which can measure them exact number. That means when you divide through that and you get exact number for both. So now my question is, so again, we have to look for a tanker with a smaller capacity, as we have to measure the exact number of small tankers from the given tankers. Therefore, HCF of 850 and 680 will be calculated. What is the HCF? And it's better to do with Euclid method. It's always good for bigger numbers not to do prime factorization, because no one has forced you to go with prime factorization. So 680, 170, 680. So final answer is 170. 170 liter capacity tanker will measure in exact number. I'll
Yes,
repeat my question. any number which has 0 at its ones place, what is sure that you'll have the prime factors? Which numbers are sure to be the prime factors of that number which is ending with 0?
2 and 5.
Perfect.
2 into
So
5 10 हो जाएगा.
exactly. So we are sure that the number which is ending with 0 will be sure having 2 and 5 as its prime factors. It may be many other factors also, many other prime numbers, but 2 and 5 for sure. So if I say 6 raised to power n, will there be any n positive integer, so the resulting number ends with 0? So question is 6 raised to power some number, will there be any number which will give us 0 at the ones place? So looking into the theorems, we factorize 6. We can see to have 0 at ones place, it must have 2 and 5 as one of the prime factors. Since 5 is not factor of 6 raised to power n, hence there is no n, there is no n positive integer, right? So if I pick another number, 3 raised to power n, will it have 5 at ones place for any value of n? That again a positive integer we are looking for, positive integer. Will there be any n? No, because